Welcome. Dear students, in this class we are going to look at what is iodine number. This is part 1 of this video. In part 1 we will look at what is iodine number, what is the significance of iodine number, and then we will look into mathematical way or theoretical way to calculate iodine number. In part 2 of this video, we will look at the definition of iodine number and we will go directly into the experimental way of determining iodine number. So let us start the part 1 of this video, iodine number. Iodine number is there, it is referred to as the grams of iodine. Grams of iodine that would add to carbon-carbon double bond in 100 gram of fat or oil. You take a sample of oil or fat, okay, and it is 100 gram. How much carbon-carbon double bond is there? How will you determine it? By adding iodine into the system. The amount of reacted iodine, the amount of iodine that reacts with this carbon-carbon double bond to give addition compound, that would be the iodine number. So what does iodine number indicate? What does iodine number give you? It gives you the amount of carbon-carbon double bond in 100 gram of fat or oil. Or you can say it is a measure. It's a measure of degree of unsaturation. It gives you an idea or a correct estimate, not an idea, a correct estimate of what is the degree of unsaturation. The next question is that comes to my mind is, why do we need iodine number? Why do we need to know the degree of unsaturation, or why do we need to know the amount of carbon-carbon double bond? The need to know is because if iodine number is more, what would be the meaning of that? If iodine number is more, it would mean that carbon-carbon double bond in that sample is more. It means that unsaturation is more. So what would happen if carbon-carbon double bond is more? See, carbon-carbon double bond, it can react with anything. So that would make that fat or that oil that contains that carbon-carbon double bond, that would make that fat or oil unstable. It would make it reactive, right? So it indicates the stability of that oil. If iodine number is less, that means the stability is high. Why? Because carbon-carbon double bonds are less. The unsaturation is less, right? So that is number 1. Number 2, iodine number, higher the iodine number, if the iodine number is more, what would it indicate? Yes, it would indicate that carbon-carbon double bond is more, right? The unsaturation is more. It would indicate that such a fat or such a sample that contains this carbon-carbon double bond, it is prone to oxidation. Oxygen can get added to it, right? It is prone to oxidation, it is prone to attack by moisture, and the oil is prone to become rancid, okay? Or rancidification of oil can take place, okay? The oil may get spoiled very easily, right? So it actually gives you an estimate of the shelf life of that oil or fat, right? Higher the number of carbon-carbon double bond, lower the shelf life, because such a bond, such a system can react with oxygen or moisture and it can become rancid. So it gives you an estimate about the shelf life of the oil or fat. The third point is, the third significance of iodine number is, it would give you an idea on drying characteristics of oil. Drying characteristics of oil. What is the drying characteristics of oil? See, there are 3 types of oils. One is drying oil, the second is semi-drying oil, and the third is non-drying oil. I shall rub this, okay, and I will continue. Lack of space in board. There are 3 kinds of oil: drying oil and semi-drying oil and non-drying oil. What are these kinds of oil? See, drying oil, if you apply a layer, it will harden. Semi-drying oil, if you apply a layer, a part of it will harden, right? Some of it will harden. Non-drying oil, if you are applying it, it won't harden. So drying oil, because it hardens, it is used in your paints, varnishes, everything. So all of them have different applications. So drying oil has iodine number greater than 120. Semi-drying oil has iodine number 120 to 105, and non-drying oil have 85 to 105. So this is the iodine number that they should have. If you know the iodine number, you will be able to determine which of these category does the oil belong to, and accordingly you can have the applications, you can enjoy the applications, accordingly you can put it into use. Okay, so this is the third point. The fourth point is, sometimes what would happen that a saturated fat is purposefully adulterated with unsaturated. It is purposefully adulterated with unsaturated fat. So you can easily find out, right, that whether it is adulterated with carbon-carbon double bond fats, right, and if it is so, how much is the amount, you can easily identify. So there are 4 applications of iodine number. Number 1, as you have seen, it gives you an idea of reactivity of that oil. More the more the iodine number, more is the carbon-carbon double bond, more will be the reactivity and less stable the oil will be. Second is, it gives you an idea of the oxidation. If iodine number is high, then carbon-carbon double bond is high, then more chances of oxidation, more chances of reaction with moisture, more chances of rancidity. It gives you, third is, it gives you idea on the drying characteristics of the oil, whether it is drying oil, non-drying oil, all these ideas, semi-drying oil, you can get the idea and you can accordingly put that oil or fat into use. The fourth point is, it can give you an idea on the adulteration of unsaturated fat into saturated fat. So these are the 4 benefits of knowing the iodine number. The next question that comes to our mind is, how will we mathematically calculate iodine number? Mathematically or theoretically calculate the iodine number without doing any experiment. This can be possible. This is possible if you know the oil, right? If you know that structure of that oil, and secondly, if you know the quantity of the oil used, you can mathematically calculate how much iodine you require, okay, and what will be the iodine number. Okay, so let us see that mathematical calculation of iodine number. Mathematical calculation of iodine number. Okay, let us see. Suppose you take an oil, glyceryl trioleate. So this is glycerol, as you know. This is glycerol, and oleic acid is this. This is oleic acid. So this is oleic acid, this is glycerol. What I am going to do is, I am going to remove H2O. I am going to remove H2O and I am going to remove it from each, okay, and I am going to pair it. So I will get glyceryl trioleate if I pair it, okay. So I will draw now the combined structure. So I am going to combine glycerol and oleic acid, which I have drawn earlier, and I am now going to write glyceryl trioleate. So this, so I am going to remove H2O and I am directly doing this, combining, linking this. I am repeating the same sequence here. I am writing oleic acid in the second linkage also. I am going to repeat this here. So now I got glyceryl trioleate, and how many iodine would I require? Here 1, 2, 3, 4, 5, 6. There is 3 double bonds in this oil or fat molecule. So, and because there are 3 double bonds, I would require 6 iodine. So I write it as 3I2. Now I will react it, and what will I get? Let me see. I get I here, I get I here, then I'll continue the sequence. Second also I will repeat the same as I have repeated in the first, that is I here, right? CH2 7, CH3. Okay. And here also I'll do the same. I here, CH3. So I get 6 iodine. I have added 6 iodines in the molecule. Now it's hexaiodo-glyceryl trioleate. Hexaiodo-glyceryl trioleate. So I have added 6 hydrogen and 6 iodine, and therefore there are 3 double bonds in this. So now let us calculate the amount of iodine that is required. As you can see, this is 1 mole, right? These are 3 moles and this is 1 mole, right? So we will calculate the molecular weight of this, right? How do we calculate the molecular weight? We have to know the number of carbon atoms, hydrogen atoms and oxygen atoms. Okay, so the number of carbon atoms, I shall rub this, okay, and I will write that molecular formula for this. Okay, the number of carbon atom is 57 H104 and O there were 6, 2, 3, 2, 4, 6, yeah. So that would be C57 H104 and O6. If you are calculating the molecular weight, it would be 57 into 12 plus 104 into 1 plus 6 into 16. So that will give you 884 gram. So you are using 884 gram of glyceryl trioleate, right? Now we will calculate for iodine, molecular weight of iodine. What is the molecular weight of 1 iodine? So that would be 126.9, 126.9. And how many iodines we used? We used 6 iodines. Total 6 iodines we used, and if you multiply it, the result will come 761.4 gram. So I am going to rub this all again. So you can see I used here 884 gram of glyceryl trioleate and I reacted with 761.4 gram of iodine. So 761.4 gram of iodine is required to add up to 884 gram of glyceryl trioleate, right? Now can you calculate for 1 gram? Can you calculate for 1 gram? 1 gram of glyceryl trioleate would require how much? 761.4 divided by 884 gram of iodine, right? Can you calculate for 100 gram? Because iodine number, the definition of iodine number is in 100 gram of oil or fat, right? So we are trying to find out in 100 gram. So we will calculate for 100 gram 761.4 884 into 100. So the iodine number that comes here is, the amount of iodine is 86 gram of iodine. So for 100 gram of glyceryl oleate, you need 86 gram of iodine. So 86 gram of iodine can comfortably add to 100 gram of glyceryl trioleate, and so that is the iodine number of your glyceryl trioleate, 86. That is the iodine number. So now you can say that higher the iodine number, greater will be the instability, right? Greater will be, more prone will be to oxidation, more prone will be it to moisture, more prone will it be to rancidification, right? And it will surely determine the drying characteristics. You can well see in what category it falls, and also it will give you an idea of the adulteration. So dear students, this is the mathematical way to calculate iodine number. There is another way to calculate iodine number. In case if you don't know the oil, if you don't know the amount of oil that is being taken, how will you do that? How will you calculate the iodine number? That we will discuss in the part 2 of this video. Thank you very much.